Given three non-coplanar vectors A, B, and C, we need to check whether the following three vectors are coplanar or not. Okay, let us begin. Now, we begin by assuming that these three vectors are coplanar. And if they are coplanar, then it is true that if we take any one of the vector, it can be always expressed as a linear combination of the other two vectors. For instance, let's say we consider the vector A vector plus B vector minus C vector, then it must be true that this vector must be equals to a linear combination of the other two vectors. That means we'll take x, multiply x as a scalar, multiply it with the vector 2a vector minus b vector plus 3c vector, and add it to another scalar y times the vector a plus b minus 3c. Fine. Now what we'll do, our next goal will be to find out the value of x and y. For this, let's simplify the right hand side. So here on the left hand side, we have a plus b minus 2c. Whereas on the right hand side, we're going to get 2 times x plus y multiplied to a vector, added to negative x plus y multiplied to b vector, added to 3 times x minus 3 times y multiplied to c vector. Comparing both sides, we get three equations. We get 2x plus y equals to 1. We have negative x plus y equals to 1. And we have 3x minus 3y equals to negative 2. Now our goal will be to solve any two equations at a time, and whatever values of x and y we get from solving those two equations must satisfy the third equation, and only then we can say that the three vectors are coplanar. If they don't follow this, then we will immediately say that they are non-coplanar. Okay, let's consider the first equation and the second equation. So here we have 2x plus y equals to 1, and the second equation is negative x plus y equals to 1. We're going to subtract the two equations. So 2x minus negative x is going to give us 3x. Y minus y goes away. 1 minus 1, that's also 0. This gives us the value of x equals to 0. Now we can take any one of the two equations and find the value of y. The y comes out to be, so let's take this equation. So y is going to be 1 plus x, since x is 0. So y value is going to be 1. So here we have obtained the solution of x and y as 0, 1 when we solve these two equations. And these two values must satisfy this third equation. Now the third equation, on the left hand side, we have 3x minus 3y. This is going to be, so we have 3 times 0 minus 3 times 1. This is going to give us negative 3, but that's not equals to negative 2. It's not satisfying the third equation. Since they are not satisfying the third equation, that means our original supposition was wrong. Our assumption was wrong. So that means the three vectors, so these three vectors are non-coplanar. So they are not lying on the same plane, hence proved.